So basically what slice is going to do is basically it's going to essentially add the last element to an array, to the existing array, remove certain elements from the existing array, and then also return back the removed elements, an array of the removed elements. So here it seems like there's basically two arrays that we can keep track of. One would be the old array, and the other one would be the new array that has the removed elements. Um, and if you guys took a look at the solution, I think that's a really clear way. We could directly act on the existing array. So we could, in this particular case, we can start directly mutating this my array. But as we're working through it, if we're mutating it at the same time, things can get kind of confusing, because as we're iterating through it, we're like mutating it at the same time. And so that might cause some confusion. And so it might be good to just separate things out, have an old array and have a new array. And then at the end, just basically rectify everything. So first, we can essentially have a we could initialize two arrays. So one array would be the existing elements array, and then second we would have a removed elements array. So these are the two arrays that will represent initially. And first we want to basically until this argument, we basically want to keep everything before that into the existing elements, because here if this started at 2, then we would keep both 1 and 2. And so we want to keep everything to the left of this index. So we would say, iterate. So in the arguments, I'll give them some names. So we can have, array, and then we can have the first argument be start index, and then the next argument will be like number to remove, and then the last would be element to add. So we can iterate from 0 until start index, and then everything in there we're going to keep. So we'll just put it into and add elements to existing elements, and then 4. So now we know how much to keep, and then we're also going to need to add this element now, because in this example we keep everything to the left of index 1, so we keep 1, and we also want to keep apples. So we then add element to add to the existing elements. So we've done that, and then now we need to, based on this number, figure out how many elements to remove. And so we can start our loop. We can go from, so where would we start this loop from? If we ended at the start index for our last iteration, does anybody have any guesses as to where we could start this new iteration? Because it'll be related to line 3 in some way. Any guesses? Yeah, perfect. So we can start from the start index. Thanks, Jessica. So we start from the start index, and then where do we want to go until? How would we know where to end? in regards to how many elements we need to put into this removed elements array, like how would we know where to end? Yep. Thanks, Arthur. So exactly. So we do the start index plus delete count because that tells us how many elements we're going to add to our existing or to our removed elements array. Because if this was 2, since this is 1, then we only add this number 2 and then we stop. But if this was 2, then we would essentially be adding 2 and 3 because we need to remove 2 elements now. So we go through here and then we add elements to removed elements. It's quite involved, but I think there's some main ideas here, and we'll get to them, about immutability and about, basically local variables and variables outside of the local scope. And so we'll go over that all in this example because I think this encapsulates all that as well. So yeah, we have that. And so now we're basically almost done. So we have our removed elements, and then we have all of our existing elements. But the problem is that this is a new array, but splice actually mutates the existing array. So we need to somehow modify this existing array. And the reason why we didn't do that right off the bat was, as I mentioned before, it's kind of confusing to modify an array as you're iterating through it. So sometimes it's just clearer to just create new arrays and then do the mutations. But we created this array, but that didn't affect our original array. Right now, we simply created a new one. And so what we need to do now is we need to basically pop all the elements off of the array. And the reason, and I want to kind of go over like what I initially thought was, why can't we just do array equals existing elements or something? If you guys saw the solution, they basically pop all the elements off and then start pushing elements into the array. But why? Does anyone have any guesses why we can't just assign the array to be existing elements and have that fix the problem? It's definitely a tricky question. But basically, it's because of the local variables. Because remember how I said back when we were talking about scope, that essentially we have this, when we do this, essentially we're saying let array, sorry about that. I'm gonna close the window. So when we do this, we're essentially saying let array equals array. So this array becomes a local variable now. And when we assign it, if we said, array, so what happens is we do let array equals array. And then so if we say array equals existing elements, that doesn't affect the outside, like in the array that should be mutated. When we have this array on the outside and we pass that into this function, basically we're assigning that array to be, we're reassigning that essentially. And so basically when we assign this array, it's not changing the outer array. We're just creating a new variable inside the scope of this function that's called array. And so even if this was the same name, it's not changing the outer one. It's only changing the inner one. So we're not really mutating the outer array if we just reassign in this case. We need to actually mutate this outer array. So when we when we do something like, so I might be confusing you guys right now, but when we do something like this, it will actually affect the outer array um, because they're pointing to the same array. So even if we're doing let array equals array implicitly, like under the hood, even if this is happening, this local variable and this outer, this global variable, they're basically pointing at the same object. So when we do this pop operation, it will actually affect this this outer object. Whereas if we were to like reassign, if we were to say array equals existing elements, this actually just makes this local variable point to an entirely different array. And it's local, so it's not affecting the global one. Whereas if you don't reassign and you just act upon it, then even though they're two separate variables, they're both pointing at the same thing. If that makes sense. That's why, I mean, initially I even thought like, why can't we just reassign this like to the existing elements? Why do we have to do the whole pop and then push? But that's because if we reassign, we're pointing the local variable to a entirely different array. And so now you're kind of, now both variables are still different. Like this variable is still different than this variable. They're not the same variable, but they're pointing at the same thing. Until you reassign it, until you say like, array equals some other array, then they're pointing at different things now. Then it's like, then it's two different variables that point at two different things versus two different variables that point at the same thing. So yeah, just for that reason, here we need to basically pop all elements from array. And then once we pop them all, does anybody have any ideas what we need to do after so now we've popped them. So now this array looks like an empty array. How can we mutate this array now? Yep. So we just like push everything from existing elements into array. And so no reassigning, just pushing and popping in order to mutate. And I believe this will handle everything. So let's try it out. We have our array, we have our start index, and we have our num to delete, and we have our new element. So we just go, step by step. We have that, and then we have our removed elements. And now we can iterate. We're starting at 0, and then we need to go until start index. So everything to the left of this index. So we're going until 1, basically, not including 1. So we don't want to include this. That's why we do less than. If we did this, then we would include it. We would include the element at the first index. So yeah, we do that. And then here, we can do elements dot push array at I. And then what do we need to do after that? We then add the elements add to the existing elements. So we could just say existing elements dot push new element. And then we need to iterate from start till the delete count. So for let, what should we do here for the start? Because we don't want to start at 0 now. I guess you guys have already pretty much answered it. So we'll just start at the start index, and then we'll go until start index until however many we need to delete. So num to delete. And then here we just add this to removed elements. Removed elements dot push array at I, and then we're almost done, but then we need to do this whole thing where initially I thought, we could maybe do like array equals existing elements. But again, that will point our local, this is a local variable. It's not the same as the outer, it's not the same as whatever's in the global scope that gets passed in to the function. It's an entirely different variable. And so when we just assign it to a different array, that's not changing this, this outer array at all. So we can't do this. We have to do something like while array.length, just pop everything off, which is actually mute. Now this is changing the outer one because although this is an entirely different variable, it's pointing at exactly the same data structure. And then we're done with that. And then so we can then add to the array I is less than existing elements dot length I plus plus. Here we can just add array dot push existing elements I, and then here we can return removed elements. Yeah, I believe this should work. Doesn't. Expected undefined to equal close. Let's see. I'm trying to figure out what the spec list is. So the second test is failing, which is here. So it equals food and clothes are stuff. All right, so I'm just gonna. This one might be a little hairy to debug, so I'm just gonna. I think this can disable tests. So I just want to focus on that one test because I feel like if I figure that one out, the other ones might fall into place. So here, I guess this is undefined. It's probably something with indexes, but let's see. I'm gonna throw some logs in here and try to only run that test. Let's see. So I'm gonna console log what my existing, wait, let me see. Oh, it looks like they don't even give a, they never passed in a parameter for the new element. And so I guess there's a case where you can't add a new element. I mean, there's no new element. So if there is a new element, then add it. Otherwise, don't do anything because, but I still think it might fail because it was missing something, but let's see. Yeah, it still fails, so I think there might be something with my indexes. So let me log. I'm not adding start index plus num to delete. Oh yeah. Right. So I skipped one step. Thanks, John, for reminding me, but just definitely I just completely forgot to. Basically, what I was forgetting to do was adding the remaining stuff after we removed this. So we removed trash in this case, but then I'm just not adding close because I'm not doing it. I'm adding everything before, and then I'm adding the new element, but then I'm not adding all of the ones after the ones I deleted back into the original array. So great catch. So here I need to do while this is start index plus num to delete until the length of the array. I need to basically add these to existing elements. Yeah, I think this should do it. Awesome. So now I'm just gonna remove all these. And usually Command D helps me to select everything, but in this editor, Command D does something else. So I'm just gonna have to manually add all those back. Nice. Thanks, John. So yeah, I just forgot to add the ones after. But does anyone have any questions about sort of why we need to do this pop instead of just reassigning, or anything about mutations, scopes? If not, then I'll just go on to the next problem, which is deeper copy. Are we good here? We're good here? I'm not going to delete it just in case. So deeper copy means that asks us to basically copy 2 layers deep. So not only 1 layer deep, which we could do with just slice, but 2 layers deep. And so I think I'd like to start off with just doing the solution for just 1 layer, which, without using slice, basically what slice probably does under the hood. But we'll just go with the 1-dimensional, and then we'll add on the 2nd dimension. So for just the regular solution, we could just, in order to copy an array, we would need to create a new array. So that's a totally different memory address. And then we just go through old array and push elements into new array. So now we made a copy of old array, and that copy is called new array, and we can just return this. But as we're going through the old array, it might be that this element is itself an array. And the way that we have it now, if we just push that element in to that new array, then that nested array is just going to be the same as the one that's in new array. I mean, the one that's in old array. Like the nested array is going to be they're going to both point to the exact same memory address. And thus, if you act on one, if you mutate one, you'll be mutating the other one. Well, there's only one array, but you'll be mutating whatever variable like you use to name that from old array. It's gonna basically change whatever variable you use to access that nested array from new array, even though you're not changing 2 things. It's the same object. So, are there any ideas like what we should do if like we're going through and how we should handle that nest? Whoa. Does anybody have any splice a copy of the array? We could definitely do that. So we could just take that copy or take that array and then slice it and then push that copy in. But I think even just like at a lower level, we could just create another new array and then just push into that, and then basically what you're saying, but a little more like a low level version of that, which is basically what it's doing too, like under the hood. But yeah, that approach works. Exactly. You're just pushing the element, you're just iterating through it again, and then pushing those elements into that array, and then pushing that array into the new array. So you're basically doing the same thing as you're doing here. It's not any different. It's the exact same thing as step 1 and 2, but you're just doing it on a new array. So if the element is an array, then create a new nested array, and then just do the same thing, like go through each element in the nested array and push to new nested array. And then at the end, you just want to push this one, push the new nested into new array. So it's the same thing as the outer one, but you're just doing it one layer deep. So this takes an array, and then just simplest case, we have a new array, and then we're just going to iterate through each element in the outer array. And then we're basically going to say, you know, what kind of conditional will we do here? Because we need to check, you know, this element this could be, you know, a number, or it could be an array. So how would we handle that? Any guesses? Yep. We could use type of. We could use array as element. Yeah. So we could do type of. Type of would give you an object. Even if it's an array, it would say it's a type. It's a type of object. So this is a little more specific. So yeah, I'm just gonna handle the not if it's not an array case first. So if it's not an array, then what should I do? Any guesses? If this element is just a regular primitive number or string, yep, then we just push element. But else, that means this is an array. What should we do in this case? It is an array. What's the first thing that we need to do since this is an array? And we're kind of copying what we've done so far, but what would be the first thing? The first action. So element is, yep, another for loop. But even before the for loop, what's that for loop gonna be doing? Like, what's the work of that for loop? So the hints would be like on line 11. Basically, we need to initialize another array because I mean, if you guys, based on how you guys do it, obviously, if you guys want to use slice, then we don't need to do this. But I'm just trying to do really just low level like basics. So we have a new nested array, and then we could just loop through, just basically do it with the same thing as the outer one is doing. Instead here, we're doing I is less than element dot length, because element is an array, like in this case. And then we can just say new nested array dot push element at I. And then after we're done looping, what's the final thing that we need to do in this case? Because we built out the copy of the nested array now. But how do we tie that all back in? Basically, we would need to somehow figure out a way to shove that back in here. And so we can just say new nested array, or new array dot push new nested array. Because this is a copy now, because it's like we're creating a whole new memory address we're creating a whole new object at a whole new memory address here that's separate from element, and so we're copying element over here, and then I think we can return the new array. Yeah. And if you use slice, it's pretty much doing the same thing. It's probably a little less code, but this is probably what slice in some way is doing, is creating some type of new object and then doing a for loop and then doing another for loop because this is a nested array. So yeah, this is kind of like, you could almost think of this as a little intro into like recursion, because this is so similar to this that maybe we could just use this function again. But but yeah, it's sort of like along that line, because we're doing such similar work that we could probably just use this function again. Are there any questions about this particular problem? If not, so Anna asks, in line 19, could we have just pushed element I in a new array? Could we just push? I think that's what we're doing. We're pushing into this new array. We're pushing element I into this new nested array. So we are doing that. Oh, but into here, if you push this element into here, then you're flattening. So that's like another common thing that people would ask, like in an interview question, is like, you have this array, like flatten it, meaning all those nested arrays, like make it so that they're all just, turn this array into, turn an array of primitives and objects into just all primitives. So in your case, like what you pointed out, if we just pushed element I directly into new array, then that would turn this into an array of just, we would get 1, 2, 3, which is a common thing that people ask, is like, turn this nested array into like an array that just is flat, completely just has no objects. So that's what that would do if we push directly in. But in this case, we just want to copy, meaning like we want the exact same values and the exact same data structures, but just we want them in a different address, memory address, so that when we start changing those things, we don't affect the original one. Because if we do affect the original one, then that could have a whole cascading range of side effects of everything that depends on that object. If we change it here and then that changes this object, then everything else that depends on that object is now reading a different object. And so it's just a lot of nasty side effects. So copying is like a really common function that we can do to ensure that now we can just mutate the hell out of that object. We can just go crazy with it, and we know that it's not affecting something else elsewhere. Okay. Awesome. So now, that's a great question, by the way, or great call out, because this kind of problem is also very common. But now we'll move on to the lecture of higher order functions. And before I start, I think it'll be helpful for us to just understand like why we even need to learn it. But let me just introduce it first, like a little bit of it first, and then we'll start seeing why it's practically useful. Just because when you start, basically it's higher order functions is basically passing functions into arguments and just passing them around and returning functions from functions and things like that. But when we just look over examples, it's sometimes hard to see like, why do we even ever need to do this? So we'll go over that really quickly, but first I'll just introduce the concept. Let's move this. Distracting. Yeah, feel free to ask any questions as I go. So higher order functions, basically functions are special because they're not special. They may seem special and different because they can be invoked and they encapsulate a bunch of code that you can reuse and call at a later point. But they really, once you create a function, it's really no different than you having created an object or an array or a primitive value and passing that flexibly into other functions and returning those values. It really can function the same way. So you can think of them as being special because they aren't that different, or they shouldn't be treated any differently than other values. So yeah, I mean, we're really comfortable with like having a function that adds two numbers and then returns the sum. So it returns a number type. We're really comfortable with having a function that returns a reversed string. So, you pass in a string and then you get out another string that's reversed. But we can also just pass in a function to a function and then call it somewhere in the function. Or we can pass a function into a function and then also return a different function. So we can have you can think of it as like a decorator almost, where, you can pass in a function and then do stuff to it and then return a different version of it. Or it's a little bit contrived, that particular example, but what they're mainly going to be used for is you pass a function into a function and then somewhere in that function, you call that function. They seem like they're in a different category, but we should try and think of them as just a normal value in JavaScript that can be passed around. So we know that we can push these into this array. But functions aren't special. We can also pass in this. And then when we log it, it'll just have a bunch of functions in them. And so you can call them too. So does anybody have any guesses as to what this will output to the console? We're basically storing functions in an array, and then we're accessing those functions, and then we're invoking them. So what would this log to the console? Basically, just calling the function. We're calling it element now instead of happy function, but it's still underlying that variable is the same function. So, yeah. Let me see. Yeah. Raymond's says it will log I am happy 3 times, and it does just that. So passing values into functions. So when we pass a string in, then we're used to passing in strings. We're used to passing in numbers and arrays into function parameters. But we can also pass in a function. So yeah, this is where the name higher ordered function comes from. Is basically it's a function that takes a function or returns a function, those are called higher order functions. But yeah, when we log the type of, any guesses as to what this would log? When we're passing in a function to this log as logs a type. So one of the guesses was that it'd be a string, but in this case, we're passing the function itself, so that's close. Yeah, it would just be a function. Just because this function, it's not really treated any differently than a string would have been or a number would have been. So the type of this function is function, and we're just logging that type. So basically, functions can be passed in as arguments to functions. And now we can run it. So any guesses as to what this would output into the console? We're passing a function in as an argument, and then we're calling it when we call that function. When we invoke the outer, like the wrapper function, when we invoke that function, we're calling the parameter that's being passed in, which also is itself a function. Yeah, Jessica says, I am happy, and that's exactly what it would log, because we could just think of this function that's being passed in as a function. It's a function, and what that function does is defined on line 7 here, or on line 8. It logs I'm happy. So when we call it, even though its name is different, it's not called happy function anymore. It's called another function. Another function just points at the happy function. So it's still calling that same function. It just has another name now. It just has another variable that it's referred to as. So yeah, basically when we pass a function into another function, typically that function is called a callback. And essentially that means like at some point we're going to call this function that we're passing into the function. So an example, so this may all seem very like contrived. Like, why would we ever do this? What's the point of all of this? Basically, it is like basically the foundation of every single action on a website. So when I hit run, everything that happens is a function, right? So like when I hit this run, everything that's going to happen in this page is wrapped into a function. So how this would look in code would be, we would have this. So we would have this button, right? Let's say this button was just an object, this run button. So basically we're in our code, we're doing something like run button dot on click, and then we're passing in the what if there's a function that run code, and then it does a bunch of complicated stuff like runs all your tests, and then it like displays success, fail, like it does a bunch of stuff, but we don't need to really know what they all do. But then we're not running this code right away, right? Like we're not just calling it right away. We need to wait for like a trigger. So when we do something like this, we would do like run button to on click run code. And basically we're passing this function in as a parameter to this on click function, because on click is just like if on click is itself a function. that's just on the run button object, the onClick, is a function that takes in a callback as a parameter, and then it eventually calls that callback when this happens. And so basically, I'm passing a function into a function, this onClick function, and this just waits. Like, I'm not immediately calling this function, but when this outer function runs, whenever that button is clicked, then it'll call this inner function. So yeah, onClick is, we can think of it as a higher order function because it accepts a function as a parameter to be called at a later point, because we don't want this function to run immediately. And if you think about it, like, this entire web page is probably like a bunch of like onClick handlers that are just waiting. It's like code that's just waiting to run, but you need to do something in order to run it. You don't want it to just like run without you controlling it. So that's sort of a practical example of higher order functions, basically just used everywhere in websites. And why would we ever need to pass a function in as a property, as a parameter of another function, is because we may not want to call it right then and there. We're just passing it in and we're saying, look, like, when this event happens, when this click happens, then call that function. So we're just sort of passing it in and delaying or waiting for some proper event to actually trigger it. So yeah, this kind of goes along with, you know, why we're even considering these topics and these concepts, is because it pretty much forms the foundation of like websites and event-based programming. So yeah, when we have this function, it takes in a normal parameter, and it also takes in a callback function. And this callback function could be anything. It could be any function that we define. So in this particular case, it says hi. So, and then it passes in that parameter. So does anybody have any guesses as to what this would output into the console? We have the says hi function that we're passing into calls with name, and then we're actually calling calls with name. So it's gonna call the says hi function. Yep, it'll say hi Sadie, because it calls that function, even though it's not named to say hi anymore. We're not directly calling it by the name that it's defined as, but callback is just another name for says hi. They both point at the same function. And says bye, along the same vein, it just calls the says bye function, because now callback will point to says bye instead of says hi. So these are just more examples of callbacks. So here, if you guys want to take a moment to take a look at this and see what this might output to the console. Calls with hello takes a function, and then it calls that function with the hello string. So essentially, this add world function becomes func becomes the func parameter. And so when we call func, we're calling add world basically. And so the result would just be the return value. Exactly. It would be hello world. It would just be the return value of the add world function. So yeah, this is an example of multiple. So there's kind of a lot going on here, but essentially the say to all function, it takes in an array and a function, and it's basically going to call that function taking in every single element of the array as the parameter. So it's going to call that function multiple times. So in this particular case, we're just basically looping over the group array and then passing that element into the say hello with name function multiple times. And so does anybody have a guess as to what this would print to the console? Basically, we're calling say hello with name to Jane, to Jill, to Pip, and to Mike. So basically, yeah, it would say hello Jane, and then it would say hello Jill, hello Pip, and hello Mike. So it would do that it would do all of them. So we're calling that same function on all of the elements of that array. And this is a really common thing too, because when you have a list of a list in an array, and you want to do something to all of them, that's a really common thing. Like, what if you wanted to capitalize every single string in an array? Then you'd probably need to call a function on every single element of that array. The only difference here is that they're just passing that function in as a parameter. And so it's kind of like there's a little bit of renaming that's going on here, because we're essentially renaming that function from say hello with name to say with name func. It's a little more generic. So the reason this is helpful is because we can pass multiple functions in, and they would all, they could all be a little different, but they would all have the same name, same generic name, but they could potentially be different. Just like how, when we create a function and we create different argument types, that gives the function more flexibility to handle many different cases. Same here, since we're parameterizing the function, we can pass in a lot of different functions. So George asks, does the order inside the parameters ever matter? So on line 13, yeah, it does matter, just because if the first parameter is going to be names in that function, and the second parameter is going to be the actual function. So if you change that up, then you would then what that would be doing is you'd be trying to invoke an array with a index of a function, and so it would just break. So yeah, the order for parameters does matter in a function. The order in which you pass them in is the order in which they get assigned, and so you have to comply with this function signature and follow the exact order. It would be cool though if it could just know based on type, like, yeah, this is a string, or this is an array, so let me just switch things up. But it's not that intelligent at this point. Maybe that'll change. So yeah, we can also pass anonymous functions in. So instead of, this is pretty much the same thing as before, but instead of defining the function and then, just passing in the name. So in the previous one, we created this function, say with hello name. So we declared it, and then we just passed it in as the argument. but we don't have to really declare it. We can just define the function right then and there. So as this line 11 to 13, if you guys want to take a moment to just take that in, basically we're just defining it within the parameter itself, which is legal, which is perfectly fine. It just kind of skips the extra step of declaring it. We're just defining it directly within the parameter, and we're not giving it a name. So we would only really want to do this if we're not going to use this function elsewhere. It's not going to be a reusable function. We're just using it in one place. In that case, if you don't want to, if you want to save the step of defining it, we could just define it directly within the parameter, because that's the only place it's going to be used. But if you want to reuse this function, you probably want to declare it outside, and so you can have access to it. My audio. Thanks for pointing that out. Let me see. Has it been happening this entire time, or just lately? Oh, it's been okay. Okay. Let me know, Raymond, if that happens again. It might be my internet. It might be. Okay, it's been happening the entire time. Let me try and mute people. Maybe that'll help. Let me see.
Say to all. Okay, function say to all names. So.
All right, can you guys hear me okay? Can you guys hear me okay? Are you guys able to hear me? Cool. Okay. So yeah, we'll hope that the internet stays strong for us. So yeah, anonymous functions, basically just declaring the function within the parameter itself, and you don't have to give it a name. You can give it a name, but in this case, it would kind of be pointless in line 11 to give this a name, because we can't really access it outside of that scope. So, on line 14, if we gave this function a name like log by, then we can't even access it in line 14. So it'd be kind of pointless to even give it a name. So that's why they're just, it's an anonymous function. You can't access it outside of the function anyways. So why waste the code? Dang, unfortunately, this already showed what this would log, but basically, again, this is just another example of parameterizing functions and calling them within other functions. So here we're passing the operation func, but the nice thing about that is we can change the operation func. So it doesn't have to be plus. So calc, the calc function, it can do both plus and minus, and we could add another one for for division and for multiplication. And because it's a parameter and we can just pass in different functions, it becomes much more flexible. Okay, so yeah, if you guys miss something, just feel free to ask. Let me see what my Wi-Fi is connected to right now. Yeah, it's connected to the. Okay, so if it keeps happening, just let me know. But yeah, this is basically gonna, for line 13, it'll add. And then for line 14, it'll subtract. So it'll be 30 and 40. respectively, because operation func in line 10, it can be whatever is passed in. So it'll be plus in one case and minus in the other. So this is something that is really common, and you guys will get experience with much more. There's a lot of these sort of callback type functions that we can use, and essentially they're shortcuts. But for each is a method that's on an array, and we can just pass it a function, and it'll call that function for each element in that array. So let's look at an example. So in this case, there's kind of some things happening under the hood that implicitly, and so we just have to kind of trust certain things in this case, because the code for each, we don't see it. We don't see its implementation. It was written by somebody else, and it just exists, and we just have to trust that it does what it does. So in this case, we're creating a function, and we're creating it. So on line, it's really important to note that on line 3, it's a string, and so that string is going to be, that argument that's going to be passed in is going to be Brooklyn, and it's going to be Golden Gate, and it's going to be London. Basically, all of the elements of that array are going to be passed in one by one in a for each callback function. So when you call that function, so when you pass in that function is going to be called on each element of the array one by one. And so it looks a little confusing because we don't explicitly, before we would have just done, for let I equals 0, and then get each element of the array, and then call that function log to uppercase explicitly on that element by grabbing it in the for loop. But a lot of coders are, I don't want to say lazy, but they might be lazy. So they don't want to write the for loop out. It does the same thing. You can do the same thing with a for loop, but it's like way less code. And so, fingers get tired. I'm not sure, but you can just pass in that function into the for each, and under the hood, it's basically iterating through each element and passing that element as the parameter to your function, even though it's not happening explicitly. So yeah, let's just look at how for each is, how I might create a for each loop. So basically what for each is doing under the hood is it takes we have an array that has all of our students. So Jackie asks, how do you deal with scope if trying to use for each within a function calling a helper function? Okay, yeah. Let me just go with a quick example first, and then I'll answer that. So that's a great question. So if we have a bunch of students, so we have Jackie and Raymond and Anna, and so we could just do something like students. How would we create a function that let's say we wanted to, what's something that we could do? Let's say we wanted to just log these names out, just shout them out. So before we would do something like, we create this function called shout out, and then I would take a name, and then that would just do how would we do this? We just do for let I, or we could just say console.log name, or say giving name shout out. So then before we would just do something like for let I equals 0. And there's nothing wrong with this. In many cases, it's really clear what you're doing, so there's no problem with it. But it is a lot of code. Like typing out that initialization is a lot of code. So before we would just do let element equals students I, and then we could do shout out name, and this should or thing. I need to call this element. But if we want to do the shortcut way, we could just do something like students.for each, and then just pass in the shout out as an argument to the for each function, because for each is a function. We just didn't create it ourselves. And what this is doing under the hood is it's basically passing each element as the argument for this function. So for each basically, like if this was a function, it basically takes in a callback, and then there's an array somewhere, and then it just basically says, for, it does the whole loop, and then it calls that callback on each element. So I'm just going to take a shortcut, and I'm just going to say, for element in array, and then it just calls the callback on that element. This is what it's kind of doing under the hood. But it has that access to that element because it's on the student's object. So if you want it to be like really, if you want it to be really proper, I guess, like students would be an object. And then this would have like, students is an array, but it's also an object. And it would have, let's say your array is, 1, 2, 3, and then it has a for each, and that's a function, takes a callback, and it does like this dot. Just do students for now. Students, because this context might get messed up because it's a function, and I don't want to confuse people yet. So let's just use students for now. So students.array. So for let I equals 0, I is less than students.array, I plus plus, and then it does callback students.array at I. So that's basically, I mean, it's not exactly the same because students is also just the actual array. But this is kind of like the same. Like if we were to see how it's like implements it under the hood, then like this might be how it's implemented under the hood. Let's see, yeah. Why is this not working? Let me see. It's being called. For each is a function that takes a callback. see if this is being called.
It is students.array.
What was that?
Isn't it students.array.length?
Oh yeah, very nice. Great catch, thank you. So yeah, I was just trying to show you guys how it might look, because otherwise it's kind of hard to trust that it just passes that array element as the argument, but it just kind of does that under the hood. And so basically we can just pass in a function and know that it iterates through each element of this array and then passes that element into this function. So let me answer Jackie's question first, and then I'll answer yours, George. Thanks, John, for chiming in. So how do you deal with scope if trying to use for each within a function calling a helper function? So do you have like an example of maybe what you mean by that, in terms of, because I'm not too sure. I mean, I kind of, do you mean like if you needed to do more things instead of just calling that function? So like technically you could do some, if you want to be really flexible, you can do something like, function, and you know that this is going to be student, right? Because the first argument that's passed in is going to be the student, or the name. We can say it's name to be more clear. And here we could just do whatever we want. Like we can call a helper function, and then we can call shout out name, and then we could do a bunch of stuff, and it would be the same thing. The other way was a shortcut. Like it was like an implicit passing of the value, but in this case we're explicitly doing it. It's the same thing. Like this function, this and this are the same thing. These two on line 7 and line 11, they're basically the exact same thing, except that one of them is taking advantage of like implicit argument passing, whereas this is just like I'm explicitly getting that name and then calling that function. But a lot of times you'll do this too just because you want to do more things. Like you don't want to just pass in a function, you want to do other stuff, call other functions, do other operations. Then you would do something like this where you have the entire function to be flexible to do whatever you want. And yeah, I think John answered the question of, yeah, it's because you want to pass in the function, not the value return. Exactly. You want to pass in the function because you want to be able to invoke it at your own whenever you want, versus if you invoked it right away, then you're essentially passing in, as John said, the result, the return value, and you're not giving, the function itself. You're giving the output. And then if you wanted to pass a parameter for some reason, would it be shout out name? Oh yeah, I see what you mean. If you want to pass a parameter, then you have to return another function. Otherwise, like if you wanted to say, if you wanted to pass a parameter, then you'd have to do something like, I mean, this is a little contrived, but I mean, if you want to pass a parameter, you could do something like this, and then you're passing a function, right? And you're not calling that function yet, but within the function, you're calling the parameter. You're passing in parameters like name, You can pass in other parameters like nickname and date of birth and favorite color. You're like basically invoking this, but you're only invoking this when you call this outer function. So you do something like that where you're essentially wrapping your function invocation, but this isn't being called. Like line 8 isn't even being called because this function is never called. So it's only when this function is actually invoked and that's going to happen later on in the for each. That's what's actually going to invoke it, that this is going to be called. So you can pass as many parameters as you like if you want to wrap that within a separate function. Versus like you can't do this, because that would mean you're calling it right then and there at line 11, versus passing in a function. And this outer function isn't being called. But when it is called later on, you're calling this inner function with as many parameters as you like. Whereas here, if you did something like this, then you're calling that function right away, and basically it's going to become undefined. So you're essentially doing like undefined. Like you're essentially passing in undefined here. Instead of here where you're passing in a function. It's an anonymous function. It has no name, but it's not a function that's being called. It's just a function that's being passed in, and you're giving control to the for each. You're saying, hey, for each, you can call this function I'm giving to you. You call it. I'm not going to call it. You call it whenever you feel it's best to call a function. So yeah, that is for each, and there's a lot of different array methods. So this is one of them. Map, filter, those are going to be other ones. And everything that map can do, everything that filter can do, you can do them with for loops. You can just create your for loop, loop over the array, and then pass each, do a bunch of logic in the for loop, and then call the function on that element of the for loop. You can do that, but this is just a shortcut. Yeah, callback. So John says it takes in the current value of the array as a first and the index as a second. So here you would say, index, and it would give you the index of this element. And so when you look up like on documentation, things like that, like for each JavaScript, it should tell you like what exactly is happening. So here it's saying, callback, the first argument is the current value of that array. And then the second argument is the index. And I guess, there's even a third argument where I believe it's the entire array. But these are all optional. Like you don't have to use them. Whereas like current value is always going to be, you're going to always be given that, and you're going to need to, I guess technically you don't need to use it, even the current value, because I think technically you can just pass in no parameters and just like hard code something. I think this should still work. It would just do like Jackie. Yeah. So you don't have to take it, but you can if you want, and you probably should, because otherwise why are you even using this array? So you can get this, and now it'll change based on all the values in this array. And then you could do something like, you could give it an index at index, and now, as John mentioned, you can pass in the index as the second parameter. And you're not the one that's creating the code to do this. It's just already written for you, and we're just using somebody else's code. So yeah, that is for each. And if you get for each, you'll be able to pick up on the other ones really quickly. So yeah, that's for each. So again, let's go over that one more time. So yeah, log with index. It's a little different than how I did it because they're defining it outside and then they're passing it in. But you could define it within the for each, within the parameter as well. You can just define it. It doesn't, you can define it in line 4 and then have it be reusable, or you could define it directly in line 8 and have it not be reusable. But they would both work. So again, string and index on line 4, we're not the ones that are creating the code to actually pass that in, but it's just happening within the for each. And you just have to trust the documentation of whoever wrote that for each code that it's passing in those arguments. And yeah, that is it for the lecture. There's a project that I'll unlock as well. This is for extra practice. If you guys want to take a look at this, I believe it's a project that, you can, I believe it creates a poem using some song lyrics or a poem or a speech. You can put it in to this function. It'll basically be a function at the most basic level, and then it'll output something that is a poem. And yeah, you guys can feel free to submit it to us, and we'll let you guys know which ones are winners in these 3 categories. So yeah, if you guys want to check out some examples of speeches and how they were transformed, when you guys get this lecture, you guys feel free to visit these links for these REPLs and check them out. But yeah, I'll unlock that. And that is the end of the lecture. If you guys have any questions, feel free to ask. But take a quick breather, and we're going to go into the breakout rooms. And then again, same thing as before, and around 9:20-ish, I'll go over some of the problems. But do we have a fellow with us today? John, are you a fellow?
Yes, I'm a fellow.
Okay, cool. Yeah, I figured. So awesome. So John is a fellow for us, for everyone. So you guys can say hi to John, and he'll be able to join your breakout rooms and help you guys. I can help as well. So feel free to ask and call us into those. John, I'll make you a co-host. And yeah, take a quick breather, and I'll be assigning you guys in a second.